Okay, here's our next little step in solving. But look at this. We have two radicals here. Uh-oh, before we can even solve, you have to remember this. What are the restrictions? We've got to address them first. But if you remember at the beginning of this unit, go back to one of those podcasts, and you'll remember that if we have two radicals like this, what we have to determine is we have to determine which restriction best describes both radicals. Huh? Watch. Find out the restriction for this guy. We know that x plus 5 has to be greater than or equal to 0. Bring the 5 over. You got x plus 5 has to be greater than or equal to negative 5. Look at this one here. You have 2x minus 1 has to be greater than or equal to 0. Bring the 1 over, right? Divide by 2, you got x has to be greater than or equal to 1/2. So which restriction best describes this equation? Okay, best thing to do, bada-bum, bada-bum. Put it on a number line. Let's see what it looks like. Here's the negative 5 out here, and here's the half right here. Now, I'm going to pick the best example, best number in the entire universe. I'm going to pick the number that goes right smack here. I'm going to pick 0. I want to show you something. If we put 0 into here, that looks like it's fine. 0 plus 5 is 5, and the square root of 5 is possible. But if I put a 0 in here, look what happens. 2 times 0 is 0. Minus 1 gives me a radical, a negative under the radical, and that's not allowed. So in other words, all of this stuff in here works for this guy, yes, but does not work for this guy, no. So what happens then is that this is not the only restriction here. Remember what we did at the beginning here of this unit when we're talking about restrictions. We're always saying, okay, shade this way to show greater than negative 5, but then shade this way to show greater than 1/2, and always, always, always choose the section that is double shaded. Okay, look for the double shade, and the reason why is because that double shaded area represents both equations. So the only restriction you need to write is this guy right here. You do not have to write the other restriction because this restriction here does not apply for this. Right? Because if you think about it, look, it has to be bigger than 1/2. And if you're saying it's got to be bigger than negative 5, that means any values in this area will work for the entire equation. It doesn't. Only where it's double shaded will it work for both radicals. So that's your weakest link. That's what I would write. So let's clean this up now, because we still haven't solved this yet. Oh my gotcha. We got to solve this puppy yet. Ha! Well, let's put that restriction down. Do you remember the restriction? X has got to be greater than or equal to 1/2. There's my restriction. Now, let's go out and solve this guy now. Okay, easy peasy. Isolate your radicals the best that you can. So in other words, I'm going to move one of them over. I'm going to move this guy over. So watch what happens. This is x plus 5. I'm just going to bring this guy over to the other side, which means all I'm going to do is change the sign. This becomes 2x minus 1. Simple. Your radicals are now isolated. All you have to do now is square them both. Square this guy, look what you get. You got x plus 5 equals to 2x minus 1, and then this becomes a walk in the park. You just have to solve this and you're good to go. All right, so first things first, I'm going to subtract the x from both sides. That's going to cancel that guy out, leaving me 5 equals 2. Well, that looks like x to me, minus 1. Now solve for the x. Add 1 to both sides, add 1 to both sides. Look at this. X has got to be equal to 6, or I like to write it this way. Beautiful. X equals to 6. There's the restriction. X has got to be greater or equal to 1/2, which we figured out earlier. So that's how you solve ones like that.